Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about solid mechanics and material subject. So in this subject already we have covered a lot of topics involved in this solid mechanics and materials like simple stresses and strains and simple shear force and bending moment diagrams and theories of failures theory part and then simple bending. So now in this today's session, I want to discuss about the problem solving and theories of failures. Theories of failures already we have covered in the previous session. So based on the theories, how to solve the problems. So I will explain in this session. So first of all, you should know about the course outcome. The student should be able to illustrate the shear force and bending moment distribution in beams. So already we have covered in CO2. In this, covered one more topic, that is analyze the theories of failures. Analyze the theories of failures. So one topic here added. So in theories of failures, so mainly 5 theories are there. One is maximum principal stress theory and maximum principal strain theory and maximum shear stress theory, distortion theory and distortion energy theory. So these are the theories we will use whenever we are designing a component. You should use these theories of failures to avoid failure for safe design. Always for safe design, you have to use some theories of failure. So now in this today's session, so I want to discuss about the theories of failure related to the maximum principal stress theory and maximum principal strain theory. And later we will discuss about other theories also. So the problem given the base and based on maximum principal stress theory. You know what is this maximum principal stress theory? But in this problem given in a metallic body, the principal stresses are 35 meganewton per meter square and minus Newton 95 meganewton per meter square. The third principal stress being 0. So the elastic limit stress in simple tension as well as in simple compression is equal and 220 meganewton per meter square. So find the factor of safety based on the elastic limit. If the criterion of failure for the material is the maximum principal stress theory. So first of all, the given data, you should write the given data. The principal stresses are 35 and minus 95. So third principal stress is being 0. This is a biaxial stresses. Sigma 1 and sigma 2 are acting. And then factor of safety you have to calculate. If the criteria of the failure is maximum principal stress theory. So now we will see the solution part. So here given sigma 1 35 meganewton per meter square, sigma 2 0 and sigma 3 minus 95 meganewton per meter square. Sigma 2 is 0. And the minus 95 meganewton, that is the compressive stress. So here elastic limit stress is 220 meganewton per meter square. 220 meganewton per meter square. Sorry, here sigma 3 is 0, sigma 2 is minus 95 and sigma 3 is 0. So sigma 1 is sigma T, working stress in tension. So now how do we calculate the working stress? The factor of safety, as per factor of safety definition, factor of safety is equal to the maximum stress, the ultimate stress or maximum stress upon working stress. Working stress or design stress or allowable stress. So this is the factor of safety. So maximum stress, that is how much it can withstand, that is ultimate stress, upon the actual working condition stress or working load or working stress, design stress or allowable stress. Suppose the material can withstand 40 Newton mega MPa, so Newton per meter square. The working stress is 5 or 10, so 10 Newton per meter square. The factor of safety is 4. So it means the material can withstand up to 40 Newton per meter square. That is the ultimate stress. You know, as per stress strain diagram, the stress is directly proportional to strain up to elastic limit. So suppose 0 to A stress and strain. So up to elastic limit, so there is no deformation. The stress is directly proportional to strain. So beyond this point, enter into deformation, that is lower yield point, upper yield point, and ultimate stress and failure point. Upper and lower yield point. Yield position. So enter into yield zone. So it can withstand up to here ultimate stress, maximum load. If you are keep on increasing the load, what will happen after deformation? It will enter into plastic zone. So as per plasticity and elasticity definition, so whenever you apply load, it elongates lengthwise or diameter wise. If keep on increasing the load, what will happen? It does not regain its original shape. So up to elastic limit only, whenever you remove the load, it regains its shape. That is elasticity property. In plasticity, once enter into this plasticity zone, it cannot regain its original shape. So it occupies permanent shape. That is called as plasticity. Already we have discussed in theory session. So here, what is asked, factor of safety is equal to maximum stress by working stress. Now the working stress is here principal stress, sigma 1. Okay, the factor of safety is elastic, the ultimate stress, that is elastic limit, the working stress, that is ET. So given it is in simple elastic limit stress in simple tension as well as in simple compression is equal and 220 mega Newton per meter square. So here given the 220 meters per Newton per meter square, substitute in this the maximum stress case, and then the working stress sigma 1. The sigma 1 is the actual principal stress, that is 35. So we will get the factor of safety. Now 220 divided by 35, it gives the factor of safety is 6.28. So that is he has asked the 6 point factor of safety. And then one more, he has asked what is the this the find the factor of safety and then criteria for failure of the material. So use this maximum principal stress theory. So according to the maximum principal stress theory, the material will fail due to the compressive principal stress. Clear? The compressive principal stress is here 95. So 220 by 95. So that is here sigma 2 and sigma 2. So sigma 2 is 95. The elastic limit stress is 220. So 220 upon 95, it gives factor of safety 2.31. So this is according to maximum principal stress theory, the factor of safety is 2.31. So generally without applying any factor of safety, there is 6.28. Clear? So like this, need to calculate the factor of safety. So next theory is according to the maximum principal stress theory. The problem is, given problem is, the principal stresses at a point in elastic material are 200 Newton per mm square, that is tensile, 100 Newton per mm square tensile, and 50 Newton per mm square compressive. If the stress at the elastic limit in simple tension is 200 Newton per mm square. So determine whether failure of material will occur or not according to the maximum principal stress theory. The principal stresses at a point given is 200 Newton per mm square, 100 Newton per mm square, and compressed to 50 Newton per mm square. So similarly in the previous problem, 200 Newton per mm square given. So determine whether failure of material will occur or not according to the maximum principal stress theory, you need to check. So the given sigma 1 is 200 Newton per mm square, that is tensile. Sigma 2 is 100 Newton per mm square, that is tensile. So those are positive sign. Sigma 3 is compressive. So this one also compressive. And the sigma T, the tensile stress is 200 Newton per mm square. The simple tension elastic limit stress is in elastic tensile stress is 200 Newton per mm square. So now according to the maximum principal stress shear stress theory, the half difference of maximum and minimum principal stresses gives shear stress. The shear stress half of the difference between the maximum and minimum. The maximum is 200. The minimum is 50. That is compressive nature. So that's why you have to use negative sign. So how much? Half into 200 minus or minus plus 250 by 2. So it gives 125 Newton per mm square. So the maximum shear stress in simple tension at elastic limit. What is the condition? Half of the sigma t. So that is sigma t is 200 upon 2. It gives 100 Newton per mm square. So as maximum principal stress, shear stress developed in the material is 125 Newton per mm square, whereas the maximum shear stress at the elastic limit in simple tension is 100 Newton per mm square. So hence, what will happen? The failure will occur. The maximum shear stress developed in the material is 125. Clear? Whereas the maximum shear stress, the elastic limit in simple tension is 100 Newton per mm square. So this value is less than the maximum shear stress developed in the material. So then the failure will occur. To avoid this failure, in simple tension elastic limit stresses, shear stress is always greater than the shear stress developed in the material. Suppose vice versa 100 the previous Newton per mm square, and this value should be 100, this one is 125. Then there is no failure. So next theory, the maximum shear strain energy theory. So this problem based on this shear strain energy. So the principal stresses at a point in an elastic material are 200 Newton per mm square tensile, 100 Newton per mm square tensile, and 15 Newton per mm square compressive. The nature of the stress is here tensile, two stresses are in tensile and one is compressive. If the stress at the elastic limit in simple tension is 200 Newton per mm square, here determine what he has asked, determine whether failure of material will occur or not according to the maximum strain energy theory. The mu is 0.3. The given sigma 1 is 200 Newton per mm square, sigma 2 is 100 Newton per mm square, and sigma 3 compressive nature 15 Newton per mm square, and tensile stress in simple tension test is 200 Newton per mm square. Mu is 0.3. So now apply this equation. For shear strain equation, 1 by 12C into sigma 1 minus sigma 2 whole square plus sigma 2 plus sigma 3, sigma 2 minus sigma 3 whole square, and sigma 3 minus sigma 1 whole square. So because here sigma 1 and sigma 2 and sigma 3 values are available given in our problem. So Poisson ratio also given the mu. So C is here elasticity of modulus of elasticity. The modulus of rigidity. Modulus of rigidity in shear stress case. So now whatever given value sigma 1 and sigma 2 and sigma 3 substitute in this equation. 200 minus sigma 1 is 200 and sigma 2 is 100 and sigma 3 is 50, but it is in compressive nature, so that's why use negative. So 200 minus 100 whole square plus 100 minus of minus 50 whole square plus minus 50 sigma 3 and sigma 1 200. So we will get 1 by 12C 95,000. So here, so 1 by 12C sigma T is that is elastic nature, elastic limit, simple tension test. In simple tension test is sigma 2 is 0 and sigma 3 also 0. Only having in elastic limit the sigma T only. So that here simplify this equation, sigma T already given. So according to the simple tensile test, 1 by 12C into 8,000, 80,000. But in previous, this one is the equation 1 and the equation 2. So values you have 80,000 by 12C and 95,000 by 12C. Now comparing this equation 1 and 2. So the total shear strain energy per unit volume due to the principal stresses is more than the shear strain energy per unit volume at elastic limit in simple tension. So hence the failure will occur. So here the shear strain energy per unit volume in unit volume due to the principal stresses. Due to the principal stress 95,000 by 12C. But in simple tension test, shear strain energy per unit volume at elastic limit is 80,000 by 12C. So this value is the principal stress strain energy value is more than the unit volume at elastic limit in a simple tension stage. So failure will occur. So to avoid failure, what is the condition? That principal stresses, the strain energy, shear strain energy in principal stresses should be less than the shear strain energy at elastic limit in simple tension ET. Then the component will not fail. So whenever the shear strain energy due to the principal stresses is greater than the shear strain energy per unit volume at elastic limit in simple tension value is greater, less than the principal stress value is more than this one, then failure will occur. To avoid the failure, always should maintain the shear strain energy due to the principal stress value is less than the elastic limit in simple tension shear strain energy value. So this is the condition for to avoid the failures. So in this session, we have learned about principal stress, maximum principal stress theory. So in this theory, the factor of safety is find out already have calculated. But according to this theory, so whatever the principal stress occurred due to the principal stress is less than the stress occurred due to the simple tension test, then failure will not occur. So whenever this value is more than this is the elastic limit in simple tension test, the stress value is less than the principal stress value, then failure will occur. To avoid this, always should maintain the greater value. So similarly, in this case, the shear strain energy theory, so already we have seen. Clear? So like this, we need to calculate. We have to use the theories of failures for safe design. So these are the references I have taken. This Ramamrutam, author name and title of the book is 10th of material. The publishers are Dhanapati Rai Publishing Company and R.K. Bansal, and title of the book is Textbook of Strength of Material, Lakshmi Publications, and R.S. Kurmi and Gupta. The title of the book is Strength of Materials, and publishers are Chand and Co. Chand and Co. New Delhi. So these are the references I have taken for this PPT. So take any one reference for other more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.